Now, okay, save your applause for the end to see if I do a good job. Now, what I'm going to talk about is, well, the title is slightly different from the one that we put on the agenda. And the reason for that is that I want to talk more in general about what the future of Java is going to be. So we'll talk about how things have changed over the last few months. Because realistically, Java has changed more in the last 8 months than it has in the last, I'd say, 8 years. And I think that's not an understatement, especially when I talk about what's been going on. So to start with, let's see where we are at the moment. So JDK 9 came out in September last year. That was the first release for 3.5 years. It had a number of new features. This is a slide that I borrowed from Oracle. I used to work for Oracle, so I feel it's justifiable to borrow their slides. And they list 85 new features in JDK 9, which is quite true. Some of them are quite smaller, some of them are bigger, and one of them in particular is very big. That's the idea of modularity. So I don't want to spend too long talking about this, but it is worth spending a few minutes going over some of the things that you need to be aware of in terms of JDK 9, JDK 10, JDK 11, from the point of view of modularity. So the first thing is actually to have a show of hands. So who here is using JDK 8 at the moment? Okay, good. Anybody using JDK 7? Okay, 1 or 2 people. No, that's fine, that's fine. Anybody using JDK 6? Okay, oh, more, a few people down the front here. Little sort of area there. Anybody using 5? Older than 5? Okay, good. Nobody's using anything older than 6 by the looks of things. Right, now let's have another show of hands. Anybody here using JDK 9 in production? Oh, a few people over there, over there. How about JDK 10? Nobody using JDK 10 in production. Okay, interesting. Right, so let's talk a little bit about the module system. As I said, I don't want to spend too long on it, but it is worth spending just a few moments on it. The key thing with the module system is to take the libraries of Java and split them up into these modules. The reason behind this is if you go right back to JDK 1.0, there were about 200 classes in the standard libraries. And I can remember when I used to use JDK 1.0, and I thought 200 libraries, I can hold all of those in my head. So I can actually remember the names of the methods and so on, and write code. If you look at JDK 8, there are now 4,500 classes in rt.jar, standard class libraries, which is great, because now we don't have to write an atomic class, we don't have to write a list interface, we don't have to write a semaphore class, and so on. All of these things are provided for us. But clearly, certainly I cannot hold all of those in my head. The other thing is that 4,500 classes, nobody is going to use all of those in one application. It makes a lot more sense to take this one big monolithic lump of libraries and split it up into more manageable components. That has a number of advantages from the point of view of speed, in terms of how to resolve methods that you need. It has advantages in terms of security, in terms of maintainability, and also size. If you're doing something like microservices, being able to create a runtime to deploy with your microservice that only contains the modules you need is a lot more effective than having to ship the whole JDK for each container. So now we have 97 modules in JDK 9. 28 of those are the Java SE modules. Those are the ones defined through the Java community process, the ones that make up the Java SE specification. There are also some other ones. So there's 8 that are Java FX, if you're using that. There are a couple that are Oracle specific. And then there are 59 which are JDK specific. These cover all sorts of things, like a lot of the tools. JShell is there, JLink is there. There's a whole variety of things that are not part of the standard specification. That's good. And then the other thing that Oracle wanted to do, but haven't quite managed, was to encapsulate the internal APIs. In addition to the 4,500 public APIs, there's also a number of classes and methods in rt.jar which are there to make the public APIs work. And right from the very beginning, Sun and then Oracle have been very clear about this, that you are not supposed to use these. The most famous of these, infamous, is Sun Minsk unsafe. The clue is in the name, unsafe. Anybody here use Sun Minsk unsafe? Ooh, a couple of people. Was that?
Use or use?
Yes. Did anyone use? Okay, anybody here use a framework or third-party library? Yeah, Spring, all those sorts of things, yeah. Right, in which case you use Sun Minsk unsafe without realizing it. And the idea that Oracle had was to encapsulate these APIs so that application code, anything outside of the JDK, could not use these APIs. That was going to break too many things. So they've kind of gone back and they've said, okay, we will allow you to use these. There are certain command line flags that you can use to turn things back on again. You can access them through reflection, you can access them through importing and so on. So there are ways of getting around that. The next thing to talk about is how you migrate your application to the platform module system. What you can do is you can simply ignore the module system. You can say to yourself, okay, I have an application, I have a set of jar files, I have them on my class path, just continue doing the same thing. So leave everything on the class path, and all of your classes through your jar files will become part of the unnamed module. That works with the module system, so it has a dependency on all the other modules on the module path, and it will export all of the public elements that are available in your jar files and your classes. So it works in exactly the same way. So long as you're not using any of the internal APIs, you can just use that and everything will work. If you then want to gradually migrate to the module system, you can start by taking your existing jar files and move them from the class path to the module path. You don't have to change them, simply move it from class path to module path. At that point, rather than being part of the unnamed module, they become an automatic module. And an automatic module is one where it doesn't have explicit module information, so the name is derived from the name of the jar file, and again, it depends on all the modules on the module path, and it exports all of the public packages and classes in your jar file. If you then want to go one step further and actually integrate fully into the module system, then you can create a module info.java file. You can define explicit dependencies on certain modules. You can say that only certain packages are going to be exported from your jar file and have it work completely with the module system. So there's a nice way of migrating from what you have now to the module system in a number of steps. As I said, the idea, one of the big ideas of the module system is to allow you to build a runtime which doesn't include all of the classes that are available in the standard class libraries. To make that simpler, there is a new command called JLink. This will create a runtime based on the modules that you specify for what you want to go in the runtime. So you can say, in the very simple example here, that we JLink with one module, Java.base. And that's the one module that has to be in every runtime that you build. When you do that, JLink will create a directory structure that looks exactly the same as the JDK. So it has a bin directory, it has a conf directory, it has a lib directory, and so on. But if you then go into the bin directory and you run Java with the list modules option, it will show you that there's only one module available there, which is Java.base. If we look at a slightly more realistic example, what I've got here is a very simple application that I created called Zap. That has dependencies on some of the JDK modules, and it also has some dependencies on other modules that I've created. So I can run JLink, but only specify my module, and the tool, in conjunction with the compiler, will analyze all of the dependencies, create a graph of the modules, and then put those into the runtime. If we run the Java command with list modules again, we'll now see that we've got java.base, we've got the java.logging API, module, java.sql, java.xml, and we've got Zap, Zoop, and Zeta, which are the modules for my application. So we have the runtime, we can then deploy that into a container and have a microservice which only contains these modules. And it'll be a lot smaller than the full JDK that you would deploy elsewhere. So that's one of the big advantages of the idea of modularity. What about compatibility? Mark Reinhold was at DevOps UK a couple of weeks ago, and he did a presentation where he said this: if your code only uses standard Java SE APIs, then it will most likely work without change. Don't know about you, but I find that a little less than reassuring. I would like to see will definitely, not most likely. But there are some restrictions on what will work when you move your application to JDK 9 from JDK 8 or earlier. And in fact, another quote from another product management person at Oracle, which is, clean applications that just depend on Java SE should just work, rather than will just work. What are the things that we need to be aware of? Well, one of the big changes with JDK 9 is, unlike earlier versions of Java, things have been removed. Up until JDK 9, things have always been added. Lots of things have been deprecated, but nothing had ever been removed. So when you moved to a new version, you didn't have to worry about things disappearing from older versions. That's not the case in JDK 9. There are a number of things that were deprecated in the past which have been removed from JDK 9. And this is actually the start of a new trend in Java. The other thing that they did was they've sort of started some work to lay the groundwork for future releases of Java. They said clean applications that only use java.se. Now, in the module system, there are modules, but there's also meta modules. Java.se is a meta module. That's a module that doesn't contain any packages, it only contains references to other modules. And in the case of Java.se, that's the 28 modules that make up the Java.se standard. There is also another meta module, which is Java.se.ee. And this is where things get a little bit confusing, because this is the enterprise edition version of Java.se. And by default, in JDK 9, these are not included when you compile code and when you run it. If you have used any of the packages in these modules in your application, if you try and compile it with JDK 9 Java-C, it will give you an error because it won't be able to resolve those particular classes. If you take an application that's been compiled on JDK 8 and you try and run it on JDK 9, if you have used packages from these modules, then the runtime will not be able to start because it won't be able to resolve those particular packages and classes. What are the things that are affected? Well, there are 6 modules that you will not have by default in JDK 9. There is a Corba module. Anybody here using Corba? Nobody. Okay, that's good. There is a transaction module, which is one that's also related to Corba, so you don't need to worry about that because nobody's using Corba. There is activation. This is related to the Java Beans framework. There is also Java XML bind, which is the JAX-B API. And then there are a couple which are related to web services. And so JAX, this is actually JAX-WS, which is if you're developing web services using the old style of things, in terms of using SOAP and WSDL, rather than the more modern RESTful web services way of doing things. Anybody using SOAP-based web services? Yes, we get a few hands with that. So this is something you are going to have to be aware of, because WS and WS annotation are things that, as I say, they relate to SOAP-based web services. If you're using the standard APIs in the JDK rather than some third-party library, then you will have to look at how your code works. Next thing, moving Java forward faster. This is kind of phrase that Oracle have come up with to explain what they're going to do in terms of changing the way that the JDK is developed and changing the way the JDK is delivered. Before JDK 9 came out in September, there were some announcements from Oracle about what was going to change with future versions of the JDK. So the first of these is the idea of a new release model. And I'm sure everyone here has already seen this, because what Oracle wanted to do was to change the speed at which they released the JDK. If you look at the previous releases, JDK 8 was 3.5 years between JDK 8 and JDK 9. It was about 3 years between JDK 7 and JDK 8. It was 4.5 years between JDK 6 and JDK 7. So there have been quite long periods of time between different releases of the JDK. The idea is now to have a much faster release cadence. Every 6 months, we are going to get a new JDK. So JDK 9 came out in September last year. JDK 10 is already with us. So in March, we got JDK 10. In September, we will get JDK 11. The idea behind this is to make the development of the JDK more agile. It's the idea of being able to respond to the requirements of the users, you, the developers, more quickly. Why should we have to wait 2, 3, or even 4 years for a simple change to the syntax in the language when we can get it within 6 months? So it's a much better idea to have releases more frequently. I think this is a good thing, that we will get more features more quickly and we don't have to wait so long for these things. The way this is going to work is by changing the development process. In the past, what happened was when a new JDK was started, a set of features would be planned for that release. And that would be that the feature list would go into that version of the JDK. Those features would be developed, and with the idea that it would take approximately 2 years to complete, when those features were ready, then the JDK would be released. If the features needed to take longer than 2 years to develop, then the JDK would get delayed. We saw this with JDK 9. With the modularity system, we had to wait longer because there were a number of delays in terms of extra work that was required to complete the modularity system and make sure that it actually didn't break lots of backwards compatibility and everything was able to sort of carry on at least mostly in JDK 9. So rather than having a set of features that we plan for a particular version and waiting until they're complete, it's swapped around. So now the idea is that every 6 months we release a new JDK and only the things that are ready get put into that particular release. If a feature is not ready in time for a particular release, it doesn't go in, it gets delayed until a future release when it actually is ready. So this, again, is a good way of doing things because it means that only the things that are ready to ship get shipped. And when they're ready, they get put into the product and we don't have to worry about long delays for particular releases. The availability of JDK updates is changing as well. With this switch to a 6-month release cycle, Oracle have said, well, trying to support all of the current releases and previous releases is going to get very complicated. And it's not manageable to keep supporting every 6-month release. To make that simpler, what they've decided is to adopt the same sort of approach that people like Ubuntu have. And they will nominate one release every 3 years as being a long-term support release. At the moment, JDK 8 is a long-term support release. The idea being that they needed to start somewhere. JDK 8 was the one that was current at the time, so they would make that a long-term support release. The next long-term support release will be JDK 11. 3 years after that, we'll have JDK 17, and that will be the next long-term support release. So every 3 years, we'll get one of these releases. Another thing that Oracle have decided is how they make binaries available. In the past, up until now, we've had the ability to download the JDK from Oracle. You go to java.oracle.com and you can find the latest release, and you can find older releases where they still have availability. In order to download those, you need to tick a box, which is the Oracle Binary Code license. I'm sure most of you are like me, you've never read the Oracle Binary Code license. You have no idea what you're committing yourself to. But I do know that there is one thing in there, which is what's called the field of use restriction. Field of use restriction goes back to the days of Sun, when they were still making money from mobile phones, having Java on them, and they said, if you wanted to use the Java platform in something which was not a general purpose computer, so any kind of embedded application, then you needed to negotiate a license deal with Sun and subsequently Oracle. So long as you were using it on a desktop, so long as you were using it in a server, then it's free to use without having to pay a license fee. Oracle have now introduced a new set of binaries. These are available through jdk.java.net, and these are a build of the OpenJDK source code. These are released under a different license, so they come under the GPL version 2 with class path exception license. The idea being that you don't have the field of use restrictions, and you can deploy them pretty much anywhere that you want to. The class path exception means you don't have to worry about contamination of your code by the viral nature of the GPL license. So you don't have to ship the source code to your application unless you want to. The other thing about these OpenJDK GPL binaries is that they will only have security and bug fixes until the next release of the JDK, which means only 6 months. Effectively, that means you'll get 2 updates to each JDK that's built. The other thing that we've been used to with the JDK up until now is overlap of updates. When JDK 8 came out, you could still get updates to JDK 7 for about 18 months, and that gave you time to move from JDK 7 to JDK 8. JDK 8 has had updates whilst JDK 9 is out and JDK 10, so there's this overlap that allows you to migrate at a more reasonable pace. For the OpenJDK binaries, there will be no overlap of updates. So once a new version comes out, updates stop at the previous version and they start for the new version. Converged binaries. This is the idea of eliminating the differences between what you get with the Oracle JDK binary and what you would get if you built the OpenJDK source code. OpenJDK has been the reference implementation for the Java SE specification. That means that everything that's in there is what's required to conform to the Java SE specification. The idea now is that there will be no differences functionally between what you would get with an Oracle JDK binary and the one that you would get if you built it from source from OpenJDK. Now, that could be the one that you download from Oracle, it could be the one you download from Azul, it could be the one you build yourself. The goal for this is for it to be completed in JDK 11, and that is pretty much done because what Oracle are doing is open sourcing some more parts of the JDK that they provide. Specifically things like Flight Recorder, that's going into JDK 11. Things like Mission Control, which are popular tools that people like to use in order to enable monitoring of applications. There's a few other things like application class data sharing, other bits and pieces that are going into the OpenJDK as open source. The other side of that is actually removing more things. So I said that JDK 9 had started the idea of actually removing things. In JDK 11, there will be some significant pieces that will be removed from the JDK, or at least the Oracle JDK. No more browser plugin, so no more applet support using the browser plugin. Java Web Start is going away, as is JavaFX. Now that doesn't mean that JavaFX is dead, because JavaFX has never been part of the Java standard, it's never been part of the OpenJDK. It is open source, there is an OpenJFX project, there are people working on that, you can download binaries of it, and so if you want to use JavaFX with JDK 11, you can continue to do that by downloading those binaries. Let's try and eliminate some confusion. I have spoken to a lot of people about what is changing with the release of Java and the JDK. And people are getting a bit confused over what some of these things mean. I have said that there will be a long-term support release every 3 years. Some people think that means that you get 3 years of updates. It does not. There will not be 3 years of updates for free updates for a long-term support release. The reason for that is that from JDK 11, Oracle have said that you will still be able to download the Oracle JDK. You'll still be able to get a java.oracle.com and you will still be able to download the JDK from there. But you will only be able to use that JDK under the license for development, for testing, for demonstrations, for proof of concept. You will not be able to use it in production unless you negotiate a license with Oracle. So that is a big change. The only free version of JDK 11 for use in production and onwards is going to be the open JDK binaries. Now again, that's whether you download them from Oracle, whether you download them from Azure, whether you build your own. But that's going to be the only free binaries for use in production as of JDK 11 and later. So if you want to continue to use Java for free, and you want to get security patches, bug fixes, and so on, then you will need to change your JDK every 6 months. That is a significant change to what we're used to at the moment. This is already starting to take effect. I updated the Java runtime on my laptop, and just to highlight that a little bit more, I've kind of zoomed in. And what that says there is changes are coming, which will impact your access to future releases of Java SE from Oracle. Corporate users will be impacted as soon as January 2019. What this means is that as of January next year, that will be when the last public update for JDK 8 comes out for use by commercial users. There will still be about a year of updates for non-commercial users. If you're at home and you've got your desktop and you're running like Minecraft or something, then you will still get updates for free. If you are a commercial user who wants to use JDK 8 beyond January next year, then you will not be getting free updates. This is the update schedule. So again, don't worry about trying to read that in too much detail. Essentially what this is a slide that's based on information that Oracle presented at a conference a little while ago. The blocks in orange are the commercial Java SE Advanced product that Oracle sell. So this covers things like JDK 6, JDK 7, because updates to those versions of Java stopped quite a while ago in terms of public updates. JDK 8, as I said, is in the middle, and as of January next year, it's only for non-commercial users that there will be updates available. If we zoom in on part of that, we'll see that in the case of JDK 11, which is the long-term support release, if you want to go from 11.02 to 11.03 and have support for more than 6 months, then you're going to be using the Oracle JDK, which, as I say, is only going to be available under a support contract. If you want to use it for free, you need to use the OpenJDK version, which is under the GPL license,
And at that point, you'll need to move to JDK 12. This, again, just kind of shows that. This is, again, taken from Mark's presentation at Devoxxed a couple of weeks ago. And he showed quite clearly, in terms of OpenJDK, how Oracle are going to be providing support in terms of contributions to the source code. And he said, Oracle engineers will only contribute to the current OpenJDK release so that they can focus on the future. And it quite clearly shows only 6 months of updates for all releases, including the long-term support ones. So I want to make that very clear because, like I say, a lot of people seem to think that long-term support release means 3 years of free public updates. Let's talk a bit about the future then. Or actually, still the current, because JDK 10 is now current. What does JDK 10 have in it? The first thing is one feature which you will notice in terms of development. That is local variable type inference. This is something that other languages have already. It's the ability to not have to specify the explicit type of a variable. And you can let the compiler infer it for you. Do not be afraid, this is not the introduction of dynamic typing. It's still very much statically typed, and so if you define a variable, its type will be set and you cannot change it. What we can do is avoid having lots of extra typing. So now we can say var list equals new array list of type string. The compiler will infer for us that list is clearly an array list of type string. Polymorphism means that we can reference it as a list of type string, and we don't have any problems in that sense. We can also say that if we want to extract a reference to a stream for that list, then we can use var stream equals list.stream, and again, the compiler will see that because list is an array list of type string, that the stream will be a stream of strings. This is a feature which some people like, some people think is open to abuse, so we need to be careful. And they have created some style guidelines to show you what's good use of var and bad use of var. One of the things that Venkat talked about this morning in his keynote, which kind of resonated with me, was the idea of using descriptive variable names. Nobody calls their child P. Quite true. So we can do things like this, where we say var string list equals, and then create a list of strings. So it's obvious that what we have is a list of strings. If we called it var SL, it's not clear that it's a list of strings. So that's a good, appropriate use of var. There's also some situations where you can get a little bit confused, because you can combine var with the diamond operator. In this case, if you say, I want a new priority queue, and use the diamond operator to allow the compiler to infer the type of that priority queue in terms of its generic type. If we use that with var, clearly we've got no definition of what would go in the diamond if we expanded it. So at that point, the compiler is going to infer that it must be a priority queue of type object. So just be careful if you use that, because you need to be aware that that's what the compiler is going to infer for you. There are a number of JDK enhancement proposals that are included in JDK 10. First of those is that the G1 collector now has the ability to use parallel threads in terms of the full compacting garbage collection cycle. This was done to make the performance of G1 closer to the parallel collector in certain situations. I mentioned application class data sharing. That's one of the commercial features that used to be in the Oracle JDK, which is now in the JDK itself, OpenJDK. So you can now share class information between different instances of the JVM on the same physical machine. There is a new experimental Java-based JIT compiler called Graal. This is something that's been worked on for quite a while. There's quite a lot of things happening in the Graal space fairly recently, with the introduction of another experimental idea, which is the Graal VM. Set of root certificates. This is again bringing the OpenJDK into line with the Oracle JDK. There weren't a set of default root certificate authority certificates, so now there are. And one small thing is the idea of consolidating 8 different repos into one for the JDK itself. Yet more JEPs, heap allocation on alternative devices. So now you have the ability to spread your heap across non-volatile RAM and DRAM as well if you want to. Continuing the removal of certain features, Java H, the tool that's used as part of the JNI, has gone. So now you use Java C -H to do the same thing. There is an internal Java collection or Java collector interface. This is something you can't access from your application, so it's not a control API from application code. It's purely for people who want to replace the garbage collector inside the JVM itself. So for us at Azul, with our C4 algorithm, actually makes our life easier because we have a clean interface to work to. Thread local handshakes is quite a low-level feature in terms of adding an improvement in terms of performance. So if you want to suspend a particular thread, in the past you've had to reach a global safe point before you could do that, and so now there's a slightly better way of doing that to improve performance. There are a number of new APIs in JDK 10. There's several of them around the idea of collections. So there are new static methods on list, set, and map, which will allow you to make a copy of a collection which is then unmodifiable or immutable. So you can create a copy of a particular collection. Related to that is the idea of using a stream and having a terminal operation on your stream so that you can gather the results into a collection, and what you get back is an unmodifiable list, map, or set. And then one else that I thought I'd highlight, which is in the optional class, you now have a new method called or-else-throw. I can't see any difference between this and get other than the name. So it does exactly the same thing. Not sure why they added it, but they did. A few miscellaneous things in JDK 10. XML input factory, the new factory method, was mistakenly deprecated in JDK 9. So they have now de-deprecated this, or maybe they precated it, or undeprecated it. But whatever they did, they removed the deprecation tag from that. They've also removed some more things. And as I said, this is the idea of sort of tidying up and reducing some of the baggage that JDK has. So the COM/SUN security auth package, which is part of the Java authentication and authorization service, 6 deprecated classes have been removed from there. In the security manager, 1 deprecated field, 7 methods have been removed. They're fairly obscure things you probably won't notice. More importantly is that the JVM in JDK 10 is now Docker aware. That's good because in the past, if you started a JVM within a Docker container, it didn't understand about C groups. So if you didn't set the heap size explicitly, it would use all of the memory available in the machine to determine the heap size of the JVM. And sometimes you could end up with your JVM stopping abruptly because it tried to allocate more memory in the heap, and it couldn't do that because the C group constrained it, and suddenly it would just stop. So that's been resolved, and a couple of other things as well. Command line flags. Yes. So in JDK 9, they removed 50 of the -XX options. And if you look at that, a lot of that's to do with the fact that they moved from using different types of logging frameworks for different areas of the JVM to a single logging framework. And so they changed a lot of the flags for things like garbage collection, logging, and so on. So 50 of those went away. Then I did an analysis, and I looked at how many flags had been removed in JDK 10. 366 -XX flags have been removed in JDK 10, which kind of shows you how many -XX flags there must be if they can remove 400 of them, and there's still lots of them left. I did look through the entire list of 366, and I could find nothing that I had ever used. So I suspect that many of them are quite obscure, and you won't be worrying about it. A few other command line flags that have gone, -D32 and -D64 have gone because pretty much we've moved to only 64-bit JVMs. And then there are 5 of these -X options, some of which are so obscure that when I tried looking them up, I couldn't even find out what they did. So -SQ no pause, I have no idea. JDK 11. This is the one that's currently in development. So things that we have for JDK 11. Dynamic class file constants. I looked at this and I thought, hang on, dynamic constants, that doesn't sound quite right to me, because it's either dynamic or it's constant. It can't be both. But this is actually sort of related to invoke dynamic. Invoke dynamic was introduced in JDK 7 to improve performance for languages other than Java, specifically dynamically typed languages that were compiled into bytecodes and ran on top of the JVM. This is similar to that, but rather than for method invocation, it's around the class file constants and being able to use those in different ways. So it's really aimed at compiler writers and language developers who are looking at languages other than Java being compiled to bytecodes. There is a new garbage collector in JDK 11, the Epsilon garbage collector, that doesn't collect garbage. So you think, okay, how does that work? Because if it doesn't collect garbage, what happens when I need to, free up space in my heap? Aha, your JVM just stops. So again, why is that useful? And the reason really behind this is more for the idea of people being able to test different garbage collection algorithms and be able to see what the impact of that algorithm is on the way that the JVM performs. So the idea is you can run your application, as long as you don't run out of heap, with the Epsilon garbage collector, see the way it performs, then put in the garbage collection algorithm, run the same thing, and see what the difference is in terms of performance. Other things in JDK 11, the modules that are not included by default will be completely removed from JDK 11, so Corba and the other Java EE modules are gone. There is an HTTP client. This was an incubating module in JDK 9 with the idea that people could try it out, see if any changes needed to be made before it became part of the standard. So now feedback's been given and it is going to be part of the standard. Local variable syntax for Lambda parameters. This is the ability to use var with a Lambda parameter. I'm still a little bit confused about this because Lambda expressions already have type inference where you don't have to use var. So you can simply say x comma y and x.process y and the compiler will figure that out for you. Why you need to add var, I don't know, but there you go, you can. Flight recorder is now part of JDK 11, already mentioned that earlier on. And then there's a couple of things related to cryptography. So there's some of these bizarre things, like this is curve 25519, curve 448. I don't know what they do really, other than they are more secure and more efficient than existing elliptic curve Diffie-Hellman algorithms. Also, we have the char-char-20 and the poly-1305, where they come up with these names, I don't know. Cryptographic algorithms, which again, better stream ciphers. Unicode 10, I always like this. So Unicode 10 has been updated as part of the standards work in JDK 11. And somehow the Unicode people found 8,500 new characters to include. And you think, where? Where did they find 8,500 characters? And it turns out the Bitcoin symbol is now going to be in Unicode. So that's obviously very important. Nishu is a character set used by Chinese women in the previous century to write poetry. Okay, it's a good idea. And then Suyombo and Zanabazar Square are both character sets used for writing Tibetan Buddhist works. So again, very useful. And then the apparently long-awaited Colbert emoji is now part of Unicode 10. Yeah. Anyway. And then there's one JEP that's still being debated, which is quite interesting. This is the idea of launching single-file source code programs, so that rather than having to compile a single .java file and then run it using Java with the name of the class, you can actually just do Java hello world.java, and it will take care of actually compiling and running it in a single thing. As I said, there's some aspects of this that still need to be resolved. Originally, the idea of putting a shebang, a hash bang, at the beginning of a Java file was proposed, but people don't like that, so that's not going to happen now. There are 303 new API elements in JDK 11. A large part of those are to do with HTTP 2. There's also 6 new methods in Swing. Swing is being updated. combo box model and list model. Okay, great. And then there's some other things which apparently are useful. So input stream now has a new method, null input stream, which will return you a method, or return you an input stream, which doesn't return anything. I'm sure there will be places where that's useful, but I'm not quite sure where they are. Similarly, a null writer could be created from the writer class, and that will basically do the same as /dev/null. You can put as much data to it as you like, and nothing's going to happen. The one useful method, path of, is a new method that will take a set of strings and return you a new path. Longer term features. So how long have I got? I've got about 5 minutes, hopefully. Right, so these are before we saw some of the smaller features that were being added to JDK 11 and so on. What about bigger things, longer term things that would typically have been something that went into a JDK earlier on? So there are a number of these projects in the OpenJDK space. Amber is about simplifying syntax. Valhalla is the idea of value types and specialized generics. Loom is looking at improving the way that multi-threading works. Metropolis is the idea of rewriting the JVM in Java. And Panama is a replacement for JNI. So I'll just spend a few minutes talking about everything except Panama. Project Amber is broken into a number of different sections. So a couple of these have already been covered. So local variable type inference and local variable syntax for lambdas we've talked about. Other things that they are looking at in terms of language features. Enumerations, enhancing these to give them the ability to have a generic type parameter. So there are certain situations where you might want to use that. If you read the JEP, you can see how that might work. There are a few things around lambdas that they want to improve, specifically the idea of using a single underscore as a variable name in a lambda expression if the parameter is not used in the body of the lambda expression. That way, it makes it easier to sort of hide the fact that it's not being used. And then raw string literals. This is quite an interesting one because up until now, Java has always struggled a bit with strings because we haven't had the ability to do multi-line strings. If you want to use certain characters, you have to escape them with a backslash, and things can get rather complicated. So now the proposal is that you'll be able to use a single backquote to start a string, and then everything after that single backquote until the next single backquote will be interpreted as a string. And you won't have to escape special characters. You can put new lines in there, and it will become part of the string. Of course, the first thing you're going to say is, well, what if I want a backquote in my string? Aha! No, you don't have to escape it, because the idea is that you can use one or more backquotes to start your string. So if you wanted to have 2 backquotes together in your string, you would do this. 3 backquotes, a string with 2 backquotes in it, and then 3 backquotes to terminate the string. So, interesting idea. We'll see how well it catches on. Pattern matching is the idea of, with switch statements, at the moment we have the ability to switch on a value. So we can switch on a string, we can switch on an int, we can switch on an enumeration. This will extend it so that we can switch on a type. If you wanted to do something like this in Java at the moment, where you had a variable and you didn't know its type and you wanted to do something type specific, you would have a complex if-else set of statements with the use of instance of, and it would be quite a long piece of code. So now you'll be able to say case integer I, case byte B, and so on, and then do something specific in the body of the case. Another thing they want to do is to extend switch statements to make it simpler for a very common situation that we have. Common situation is that we switch on a value, and then we want to assign a different value based on that. So here I've got a switch statement where I switch on the day of the week, and then if it's Monday, Friday, or Sunday, the number of letters is 6. If it's Tuesday, it's 7, and so on. So what we're doing is we're assigning a value based on what we've switched on. To simplify that, the switch statement will become an expression so that we can return a value from it and assign that to a value. So we can say, in this case, number of letters is switch on day, so we're now assigning the return value of the switch statement to number of letters, which means we don't have to put it in every case statement. And then what we'll do is have each case statement simplified by having comma separated lists rather than colons, and we'll steal some of the syntax of the Lambda expression to say that the return value in the case of Monday, Friday, Sunday will be 6, in the case of Tuesday it'll be 7, and so on. We could also have a situation where we throw an exception because we might need to do that. So you either return a value or you throw an exception. Project Valhalla. Java has always had the idea of primitive values and objects. And primitives were put there because of performance. When Java was very new, if everything was treated as an object, it was going to perform not as well as people wanted it to. So they put primitives in there for performance. Objects give us all the good object-oriented things like encapsulation, polymorphism, inheritance, and so on. So the problem we face is that we can't use primitives in certain situations. If we want an array list, we can't do an array list of type int. We have to make it an array list of a specific type, not a primitive, in which case we say array list of type integer, and that has a lot of overhead because now suddenly we have to box everything into an integer object, we have to allocate space in the heap. Once we've finished with that, we need to retrieve the value, and then we need to garbage collect it. So there's a lot of overhead in terms of having something like that. So what Project Valhalla is about is value types. The idea of something that codes like a class, looks just like a class, but behaves and works like a primitive from the point of view of performance. And essentially what they're saying is, time is over, but I'm not finished. Okay, so the idea is that rather than having an integer object where you say, okay, let's create an integer object with a value of 3, I want another integer object which has the value of 3 in it, so I'll create another object. They're both the same. They both have the value of 3 in them. So let's just create one and have everything that needs an integer with a value of 3 in it point to that one object. And so it becomes a truly immutable thing. So it behaves like a class. You could have methods, you can have fields, you can implement interfaces, you can do encapsulation, you can even be generic. But you can't change it. So it truly is immutable, and it can't be subclassed either because of that reason. Project Loom, again, this is trying to look at how to make life better for multi-threading. Right now, we tend to use a lot of asynchronous types of frameworks, like RxJava and things like that, to try and get around the problem of having many, many threads in our application. So what we want to do with Project Loom is to simplify things and have a lighter weight approach to threads built on top of the operating system threads. What that's going to equate to is the idea of fibers. And fibers are like the idea of green threads from the very early days of Java. Essentially, it's threads implemented at the JVM level that map to the operating system threads. Because the JVM is then able to schedule those threads and do the context switching, it can do it at very, very low overhead. In fact, almost zero overhead for task switching. Half of that's already there. The scheduler from the fork join pool turns out is very good for this kind of thing. So what needs to be added is the idea of a continuation, which is essentially a sequence of instructions that will be executed in a single context. Last one to talk about is Project Metropolis. This is the idea of rewriting the Java virtual machine in Java, which gets a bit confusing because you think, hang on, well, if the Java virtual machine is rewritten in Java, don't I need a Java virtual machine to run my Java virtual machine? And then you get into this sort of recursive problem. No, because you can compile Java not into bytecodes, but into native instructions. So this is going to use some of the work that's been done with Graal. There's a number of things that still need to be looked at here, because in terms of getting performance of AOT compiled code versus JIT compiled code and all those sorts of things. So this is a research project, really, and whether it actually comes to something which we see in reality may be something that takes a long time, if ever. So just to finish off then, yes, I am finishing, really I am. I will briefly mention Zulu Java, which is from Azul, because this is our distribution of the OpenJDK. We build OpenJDK, we pass all the TCK tests. We support older versions, so we go all the way back to JDK 6. We also have nice wide platform support, 64-bit Windows, Mac, Linux, 32-bit Windows and Linux, ARM32, 64-bit, and PowerPC. You can download it for free from our website. If you want support, we'll very happily talk to you about extremely reasonably priced support. So just to summarize, because I know I've got to finish, so Java continues to move forward. New release cycle every 6 months means faster access to new features. The availability of updates is going to be an issue, and how you deploy in terms of which version of the JDK you deploy to is going to be something you need to think about very carefully. Lots of ideas for new features in terms of Java, type syntax, or syntax of the language itself, fibers, value types, and so on. Lots of good things coming in the future. And I really do believe that Java will continue to be the most popular development platform on the planet. So with that, spasiba.